This video presentation is on Unit 3 with regards to Math 1 to 2, that's Statistics 1, and it's on discrete probability distributions. It can simply be put as probability models for numerical discrete values. So there are some important points that are laid out there. It says discrete probability distributions are numerical probability models for random variables. A variable has a finite or countable number of values. Okay, so that's a discrete variable, that is. So we say the variable has a finite or countable number of values, so because it's discrete. And there's a very important term called a random variable now. So you have variable and you have random variable. A random variable is a numerical variable, okay, whose value depends on chance. Okay, the important point here is that the variable is numerical, it can be discrete or continuous, and very importantly, the values that it assumes has a probability value attached to it. Okay, so that's why it's called a random variable. So I think this point also needs to be mentioned. Apart from being numerical, the value that it can assume has a probability value attached to it is probabilistic. Okay, that the values that it can assume will occur. Now we will only be dealing with discrete random variables, right? Countable random variables. Random variables are denoted using uppercase letters such as X, Y, S, etc. So it goes on to say that discrete random variable can have certain distinct values. For example, 1, 2, 3, 4, 5, or 6 in the case of throwing a dice. Now, these values 1, 2, 3, 4, 5, and 6 has a probability of occurring. That's why it's called a random variable. Okay. These values depend on chance. These values depends on a probability value. Okay, now you have what you call a probability histogram, which is a bar chart in which the horizontal axis corresponds to the value of the random variable, and the vertical axis represents the probability for each value of the random variable. So that stresses the point that you've got the term variable, but once you have the term random variable, this incorporates the probability characteristic associated or attached to each value that this variable can assume. So now you have the mean and the variance and the standard deviation of a probability distribution. Okay, you can measure the central tendency of a probability distribution with its mean and measure the variability with its variance and standard deviation. So the mean that we are going to be looking at here is population mean, which is symbolized by the Greek letter mu. So it says you can, each value of x is multiplied by its corresponding probability and the products are added. So this will give us the mean, and it's also called the expected value, written as E of x. So mu now is equal to the sum of each value times its probability value, or E of x is equal to the sum of xp. For the variance now of the probability population, which is given by the symbol sigma square, some of the Greek letter, also written as variance of x. There are two formulas. Sigma squared is the sum of x minus mu all squared times p of x. And the second method, variance squared, is equal to the sum of x squared times p of x minus mu squared. Now the standard deviation now is the square root of the variance. Okay, and here we have it written here. So let's look at example 3.1. A fair dice is thrown and the number on the dice is the random variable x. This is construct a probability table, probability model. So probability model is another way for saying probability table to represent all the outcomes. And another question, what is the probability that the random variable x is 2? So there are 6 possible outcomes, all equally likely. So the probability distribution table will look like this. So this one here is the probability that you get a 1, the probability that you get a 2, that you get a 3, that a 4, that a 5, that a 6. Okay, which is 1 over 6 for each, all equally likely. And the probability of x being equal to 2 is equal to 1 over 6. So this is a discrete probability model, a discrete probability distribution. And here the value, the random variable is the number on the face of the dice. Okay, so when you throw the dice, it's possible to get a 1, 2, 3, 4, 5, or 6. These are the values that this random variable can assume. And each value has a probability value associated to it, which is equally likely. In that case, it is 1 over 6. It's important to note that the number on the dice is a random variable because the number on the dice has a probability of occurring, okay? Either a 1 or 2 or 3 or 4 or 5 or 6, and each value has a probability of 1 over 6 occurring when the dice is thrown. So this is why this variable is called a random variable, okay? Because there's a random chance that its values will occur, either 1, 2, 3, 4, 5, 6, with each throw. So the probability that the face on the dice has a 2 is equal to 1 over 6. So please pay attention to the difference between variable and random variable. Once you mention random variable, once you mention the word random, you are incorporating the characteristic of the probability value associated with each value of this variable.